Hello everyone. In this tutorial, I solve a math problem in communication system. So here the problem, a signal m of t of bandwidth b equal 4 kHz in transmitted using a binary component PCM with micro equal 100. Mu equal 100. Compare the case of L equals 64 with the case of L equal 256 from the point of view of transmission bandwidth and the output SNR. So, solution. Here L equal 64 and N equals 6. Okay, and the transmission bandwidth is NB equal 24 kHz. Clear? Cause NB means the value of N is 6 and B is 4, and 6 × 4 is multiplied after 24 kHz. So in that case, the equation S naught by N naught equal alpha plus 36 dB. Okay, so here alpha equal 10 log 3 by ln 101. So after the calculation it will be minus 8.51. okay, and hence the S naught by N naught, that's the S naught by N naught. What is the value of S naught by N naught? So here S naught by N naught equal 27.49 dB. After the calculation it would be 27.49 dB. okay, so for that's the for L equal 64. And next one in my math, L equal 256 for this. So L equal 256 and N equal 8, and the transmission bandwidth will be, so transmission bandwidth B equal here in my math is 4 kHz. So transmission bandwidth NB equal 8 × 4 kHz equal 32 kHz. okay, so the equation S naught by N naught equal alpha plus 6n equal the value of alpha, we know that minus 8.5. okay, so minus 8.5 plus 6 × the value of n is 8 equal 39.49 dB. okay, so the difference between two SNRs is 12 dB. okay, so here is 27.49, so here and here is difference 12.4 dB or something like that. So which is ratio of 16. Thus the SNR for L equal 256 is 16 times the SNR for L equal 64. The former requires just about 33% from more bandwidth compared to the later. So thank you everyone, and see you in next tutorial.